we will be thinking like a geospatial scientist using the geospatial inquiry process. This process consists of 5 parts. 1. Ask a geographic question. Something like, why are there so many traffic accidents at the intersection of Tamworth and Little Haywood? 2. Acquire geographic resources, or gathering relevant information. For example, gather historical maps of West Auckland, analyze the statistics, and create a layer that illustrates the number of traffic accidents in your area over time. 3. Explore geographic data. Turn your data into tables or charts and incorporate it into your map. This information could tell you things like which intersections in West Auckland don't have traffic lights, or which streets are one-way only. 4. Analyze geographic information. The plot thickens. With all your new data layers, look at the map, thinking about the factors that could make Tamworth and Little Haywood such a dangerous intersection. Is it the rail crossing to the south, or the lack of any stop signs? 5. Act upon geographic knowledge. With your conclusion, you should now have an informed decision about what made a seemingly normal intersection so dangerous. Think of a solution to the problem. Is the time right for Tamworth and Little Haywood to upgrade to a traffic light? Now that you're thinking like a geospatial scientist, let's dive into GIS maps. GIS maps rely on 3 different data structures: points, lines, and polygons. Points are used to make point features on a map that appear as small as a dot. For example, on a map of the United States, point features could be something like state capitals or major cities. Lines are features that can be represented with multiple vertices, such as roads, hiking trails, or streams. Polygons are map features which are 2-dimensional and cannot be represented by lines or points, such as lakes, state boundaries, or baseball parks. Using only these 3 data structures, every kind of map imaginable can be created. One relevant piece of information concerning maps is a map's scale. Scale describes the relationship between the size of something on a map and its size in the real world. For example, a map with 1:1 scale would show everything on the map exactly the same size as it appears in the real world. A map with 1:2 scale would show things in the real world at half their size on the map. A map with 1:4 scale would show real-world objects at a quarter of their actual size on the map, and so on. For example, this map of the United States has a scale of 1 to 13,500,000. This is considered a small-scale map because it covers a large area. On the other hand, large-scale maps cover small areas, such as a city park or a school layout. It is important to know about scale so you can put this information on your map. Other geospatial scientists can use this information to make calculations which could give them useful data for their own maps. By this point, you're becoming quite the geospatial scientist yourself. The final thing to learn is one of the most powerful tools in GIS, layers. Maps start with a base map and are covered with feature layers. Base maps show the underlying geography of the region, contain general information that is already known, such as political boundaries, cities, and roads, and provides a place for your other data to rest. Feature layers contain additional information such as hydrography, land use, power lines, and any other data that can be layered over the base map. Note that the order of the layers can be important in certain situations. Spreading the word about National Youth Science Day is a great way to get more people involved in fun, experiential learning. You can do this by tweeting about your mapping experience and completing the post-evaluation listed below to help 4-H make National Youth Science Day better every year. Thanks, and happy mapping!